Hello everyone, welcome back to the DPS online learning platform. Today is day 4 of chapter 1 real numbers. Today we are going to start the first question, prove that root 3 is irrational. So before beginning this sum, let me tell you one thing, that a rational number can be expressed in the form a by b, where a by b can be expressed in the form terminating or non-terminating repeating. On the other hand, irrational numbers cannot be expressed in fraction form. That is, irrational numbers takes the form non-terminating and non-repeating. So, how to do this particular sum? To prove this sum, we are going to use methods of contradiction here. What is this methods of contradiction? First of all, we are going to assume that root 3 is a rational number. We have to prove that it is irrational. But we will assume that it is a rational number. And we will prove that it is wrong. So let us begin this sum by making an assumption. Let us assume that root 3 is rational and let its simplest form be a by b, where b is not equal to 0. The slight simplest form means of the form a by b for b not equal to 0 means, so it means that a and b are integers having no common factor, no common factor other than 1. That is, we can say that is a and b are co-prime. What do you mean by co-prime? Co-prime means pair of numbers whose HCF is equal to 1 is called a co-prime pair. So here we find that a and b are co-prime pairs. Now, we know that we have assumed that root 3 is of the form a by b, where a by b is in its simplest form. That is, already I have written here that they don't have any common factor. They have no common factor other than 1. So for this, first of all, let us square both sides. Just see each and every step, what I am doing in every step. One by one, line by line. So I am going to square both sides first. Okay. Squaring both sides. Okay. After squaring both sides, we are getting 3 equals to a square by b square. And then we cross multiply. There is nothing in the denominator of 3 means 1. If we cross multiply, we will get 3b square equal to a square. Now, if 3b square is equal to a square, and if I say that, now you just analyze once properly. Can I say that 3 divides 3b square? Yes or no? Yes. Because 3b square is a multiple of 3. And as a square is also equals to 3b square, so obviously 3 will also divide a square. So in the next step we can say that 3 divides a square. What is the reason? Since 3 divides 3b square. And as both are equal, so if this is divisible by 3, obviously the other part on the right hand side will be also divisible by 3. Because they are equal, so we can say that 3 divides a square. In the next step, I can write that 3 divides a. Now what is the reason 3 divides a? This line is very, very crucial. Now see, everyone just note down. Now tell me, what is 3? 3 is a prime number? Yes. Now what is 6 square? This is a perfect square. Now do you all agree that 3 divides 6 square, that is 36? Yes, because 36 when divided by 3 It's completely divisible and the remainder is 0. Now can I say that if 3 divides 6 square, if 3 divides 6 square, 3 will also divide 6? Yes. So it is only possible when the number is a prime and the number which we are dividing is a perfect square. So that prime number will also divide 6. That is square root of the perfect square. What is square root of 6 square? It is 6. So as 3 is a prime number and divides a perfect square, that is 36, it will also divide, this will also divide the square root of perfect square, that is 6. So as 3 divides a square, where 3 is a prime number, since 3 is prime and divides a square, so it implies 3 also divides a. Note down, just this is very important line. Okay everyone, next. So as 3 divides a, can I say that if 3 divides a, if suppose 36 is divisible by 3, means 36 can be expressed as 3 into 12. If suppose 12 is divided by 3, it means that again 12 can be expressed in the form 3 into 4. So if any number is divided by divisible by 3, it means that that number can be factorized and one of its factor has to be 3. It can be factorized into the form 3 into some integer. Here that some integer we are talking about is what? 12. Here in this case the integer which we are talking about is 4. So here in this case if 3 divides a, it means that a can be expressed in the form 3 into some integer. Let where m is some integer. Okay, m is some integer. Mark it as 2 here. Now I am saying 2 because mark this as 1 because you need this here. Okay, in order to move ahead, we need this equation. Mark it as 1, and we have what we have proved? We have proved that a is a factor of 3. We have proved that a is a factor of 3. A is a multiple of 3. We have proved this and mark it as equation number 2. Now putting a equals to 3m in equation number 1. So after substituting the value of a equals to 3m in equation number 1, we find that we have 3b square equals to 3m whole square. Please note down, because the value of a is 3m, so it will be how much? 3m whole square. So we have 3b square equals to 9m square. I am erasing the first part. Please note it down in your copy so that it will be very easy for you all to understand. So as 3b square equals to 9m square, so we find that it can be reduced and written as b square equals to 3m square. Clear everyone? 3 3s are 9, 3 gets cancelled. Next. Okay, 3 3s are 9, so it gets reduced to b square equal to 3m square. Now next, can I say that exactly the same way what we have done here in this line, after this line, the same thing I can write here also. As I can say that 3m square is divisible by 3, and as b square is equal to 3m square, so I can say that 3 divides b square. Why? Because 3 divides 3m square. So as 3 divides 3m square and both expressions on the left as well as on the right are equal, I can say that 3 also divides b square. In the next step, we can say that 3 divides b. Why? As we know that 3 is a prime number and b square, this number is a perfect square. So since 3 is prime and divides b square, so it implies 3 divides b as well. Clear? So if 3 divides b, can I say that b is a multiple of 3? So let it be 3 into some integer. If b is again a multiple of 3, it means that what? B will be what? 3 into some integer. Okay? B will be some integer. b will be equals to 3 into some integer, let it be n. We are assuming that b equals to 3n. We are taking this let where n is some integer, okay, and mark it as number 3. Mark this as number 3. Now from 2 and 3 we come to the conclusion that from 2 and 3 A and B have common factor, and what is that common factor? 3. 3 is the common factor. How do I know? Because A is also expressed in the form 3n, B is also expressed in the form 3n. It means that A and B both have common factor, and what is that common factor? 3. So from 2 and 3, A and B have common factor 3. But we find that this line contradicts the assumed fact. What was our assumed fact? Our assumed fact was that A and B have no common factor other than 1. But what is the common factor we are finding? That A is equal to 3 into n, B is equal to 3 into n. So we are finding that A by B is 3m by 3n. So what is the common factor? 3. So we are finding that A by B is not in its simplest form. Its simplest form is m by n. And what was the common factor? What is the common factor? 3 is the common factor. We have proved from 3 and 2. So from 2 and 3 we find that A and B have common factor 3. And this contradicts the fact. Contradicts the assumed fact, we can say. Contradicts the assumed fact that root 3 is a rational. Root 3 is rational, okay? This contradiction has arisen because of our wrong assumption. Okay? So this contradicts the assumed fact. What was the assumed fact? The assumed fact was that root 3 is a rational number of the form A by B, where A and B have no common factor other than 1. That is, A and B was what? Was assumed to be a co-prime pair. But here we are finding that no, A and B have common factor. What is that common factor? 3 is the common factor. And as 3 is a common factor, it means that A and B are not co-prime. They can be further reduced and written in the form m by n, where 3 is a common factor we have proved in number 2 and number 3. So, is a rational, and this contradiction has arisen because of our wrong assumption. This contradiction has arisen because of our wrong assumption. Hence, root 3 is irrational. Hence, we have proved that root 3 is irrational. So, how we have used the methods of contradiction? Note down, everyone. Initially, we have made an assumption that root 3 is a rational of the form A by B, where A and B are co-prime. And in the last line, we have proved that no, A and B are not co-prime. So, hence we can say that root 3 is irrational. Thank you, and just go to the second link where I will be explaining you the second sum.